In this video, I'll go through the physics ball on a ramp challenge that we'll do in class. We'll actually be using a Hot Wheels track and a Hot Wheels car instead of a ball. So you'll set up the track as a ramp as shown, situated on a table. The car will be situated at the top of the ramp. You'll let it go, it'll roll down, and then it will launch at a horizontal velocity from the edge of the ramp. Now I'll outline 3 steps for you to complete this challenge. Step 1, use the work energy theorem and law of conservation of energy to estimate the initial horizontal velocity. I'll go through this step shortly. Step 2, you'll measure the vertical displacement or the height of the table using a ruler. Step 3, use known values and your Suvat equations to predict the range of the horizontally launched car. As mentioned in class, work is done on the ball to lift it to the top of the ramp. This process increases your gravitational potential energy. So when the car is released from the top of the ramp, it gains kinetic energy on its way down. And at the end of the ramp, all of the potential energy has converted into kinetic energy. So now we can equate our gravitational or changing gravitational potential energy with the change in kinetic energy. When the ball is at the top of the ramp, it just possesses the gravitational potential energy, so we can say that the initial kinetic energy of the ball is 0. So we can cancel that out. Now this becomes, the first thing you should notice here is that you can cancel out the mass. Now we can solve for velocity. And since the velocity off the edge of the ramp is horizontal, we can say that this velocity is the initial horizontal velocity. So step 2 is measuring the height of the table, or delta y. And step 3 is to use these values plus any other known values plugged into your Suvat equations or relevant Suvat equations to be able to calculate and predict delta x, or the range that the ball will travel in the horizontal direction. After that, you'll go on and undertake the investigation and then compare your measured result to what you had predicted.